I can go to Panama, to Costa Rica, to Mexico, to Antigua and get stem cells as an American citizen, but I can't get them in the United States. When are they going to be legal here?
You know, that is a great question that has been plaguing all of us in the industry for decades now. I think the United States is sort of behind the times on this.
There's been a lot of controversy over the years about stem cells.
If your baby was born with an extra set of kidneys, extra set of lungs, and an extra heart, would you throw them out at birth? And that's what you actually have when you have a supply of stem cells that can be used in these purposes.
Let's do a stem cell 101 so folks understand why folks are excited about stem cells.
Just like you renovate your home to keep it in perfect operating condition, it's best to renovate with the original materials that were used to build it in the first place.
Hey everybody, welcome to Moonshots. Peter Diamandis here. We're about to have a conversation about a disruptive technology in the longevity and health space. It's called stem cells, and you've probably heard about it, but this is a deep dive in Stem Cells 101 with one of the extraordinary leading figures in the field, Dr. Bob Hariri. Bob is the chairman, founder, and CEO of Celularity. He's an MD, PhD, 170 patents, one of the leading thinkers on using stem cells for autoimmune disease, for fighting cancers, for other conditions. He's an adjunct professor of neurosurgery. He's a co-founder of Fountain Life with me, one of the most extraordinary thinkers on the planet. And he's going to walk you through where they are today, where they're going, why you should consider them, what you've heard about them in the past, and why you thought they might not be safe, but what the science and technology shows us for the future. For me, this is a critically important tool in my longevity and therapeutic tool chest. I just finished a book called Longevity Guidebook that talks about how to slow, stop, reverse aging, how I've used these technologies to reverse my aging. You can check it out at longevityguidebook.com or in the show notes below. All right, let's jump into this incredible conversation with Dr. Bob Hariri. Welcome to Moonshots. Hey, buddy, good to see you. So I have a question for you off the bat. I can go to Panama, to Costa Rica, to Mexico, to Antigua. I can even go to Bali, where Genting just created a stem cell facility, and get stem cells as an American citizen, but I can't get them in the United States. When are they going to be legal here? When are they going to become available?
You know, that is a great question that has been plaguing all of us in the industry for decades now. It's really a phenomenon related to the very conservative regulatory nature of the FDA and the systems at work behind testing, validating, and proving the safety and efficacy of therapeutics. And so I personally believe that we've been working with stem cells in one form or another for over 30 years. In fact, bone marrow transplantation is stem cell transplantation. So
Sure.
This has been around a long time. My personal perspective is that cell therapy in almost any iteration in the unengineered form is intrinsically safe. And so that's why a lot of jurisdictions, very, very active in Asia, you're going to see more activity in Eastern Europe and in the Middle East. They are very receptive to at least providing an abbreviated pathway to approval, right? And so when you say, are they legal, what you're really asking is, have they been approved by the regulatory community? I think the United States is sort of behind the times on this. And what it needs is it needs a little bit of courage. It needs a little bit of willingness to accept the fact that the value of the therapeutic potential of these things outweighs the potential nominal risk of some uncertainty about long-term safety. We've been doing stem cell treatments in patients for decades and decades and decades. We do not have that long-term safety signal that should concern people. But I do believe that there are other forces behind why there is this very kind of resistant approach to approving and making these products available to patients.
You know, and we'll talk about this because we know so many people who have had significant positive impacts from cellular medicine, from stem cells. And I think of it as one of the fundamentals of the pro-longevity regenerative medicine decade ahead of us. And it's just sad to have to actually, flee the country to go and have access to this tech. Now, I'm biased, right? I'm your vice chairman of Celularity, and Celularity is a cellular medicine company, full disclosure. Bob is, in my mind, the leading figure in this field. He's the first person to ever really give me what I would call, massive enthusiasm or even religion on stem cells. So I want to get into it. I want to do a stem cell 101 for folks to understand what are they, why are they valuable, why are folks like flying, in the book behind you, Tony Robbins' photo there, where you and I co-wrote this. I mean, the opening chapter talks about him having this massive accident and going down for stem cell therapies in Central America. And instead of going, down the street to do this. So let's do a stem cell 101 so folks understand why folks are excited about stem cells. I mean, you are one of the original pioneers in this area, and I want to get into that. But what are stem cells? Why are they important? What's cellular medicine?
So look, I think everybody understands that at the moment of conception, when sperm and egg come together, a single cell is created that is the first primordial, what we call a totipotent stem cell. And from that single cell, every cell that ever occupies your organs and tissues in your body is derived. So
all 40 trillion cells that make me up.
40 trillion cells that are being renewed and recycled over and over and over again in your life. Think about the replication fidelity of taking one cell and making maybe 200 to 300 trillion cells in your lifetime from that single cell. So think of that's where the power of stem cells really resides. So let me take a step back and try and explain in a broader way the significance of this biologically. So we all come from a single cell. That is the first stem cell that ever exists with our DNA composition to it. And then those cells divide, and then some of them specialize to become brain cells, hair cells, bone cells, heart cells. And that specialization process is called differentiation. What's really cool about stem cells is they reserve the right to specialize or make a copy of themselves. That's what keeps our system capable of going through this constant renovation and renewal process. Now, what's important to keep in mind is think about the stem cells in every tissue of your body as being your natural repair kit for your body. So after conception from that original totipotent stem cell, numerous other versions of these cells, including some cells which take on characteristics of a certain tissue type, that's called a tissue lineage, they will actually go to build the final tissue and organ. They'll go to build the heart or the brain, and some of them will remain in stem form. And they sit there in what you and I often call the regenerative engine. That regenerative engine resides there to participate in the renovation process that keeps us healthy and young.
So let me slow this down a second. So what you're saying, okay, we start with one cell. It replicates eventually to form a full embryo. My niece is delivering today, so excited. She has a LifeBank USA kit there to store her placental stem cells. We'll get to that in a little bit. But it becomes that original totipotent stem cell versus pluripotent stem cell, we'll define that in a minute, becomes every tissue type. So it becomes skin, bone, ligament, cartilage, neuron, hepatocyte, lung, everything.
Yep.
And so those are when a cell differentiates into a tissue type.
Correct.
But within, and you taught me this, within every tissue in our body are these stem cells that can then differentiate into lung, in the lung, into liver, in the liver. You have brain stem cells that can differentiate into brain tissue. You used an amazing analogy that I love and I've used often, and I just wrote about in my longevity guidebook of the repairman in the mansion. Would you give that analogy again?
So what I've often said is that just like you renovate your home to keep it in perfect operating condition, it's best to renovate with the original materials that were used to build it in the first place. And it's one of the reasons why good contractors will often leave you a supply of tiles and countertops and plumbing supplies and so on, so that as you're going through the process of repairing over the years, you're repairing it back to perfect condition. Nature does that for you by keeping a little supply of stem cells in every organ and tissue of your body. And those stem cells get called upon to do the repair process. It's the natural repair kit. Now, over time, you exhaust that supply. And we often think of the aging process, one of the hallmarks of aging, being that you simply use up your stem cell reservoir. And it kind of makes sense, right? Just like you would use up the tiles that are left over for renovating your bathroom, you can use up the stem cells as well. Now, it's important to keep in mind that what makes a stem cell so valuable and useful is its ability to specialize in a versatile way, meaning that it doesn't necessarily have to be fate directed. So stem cells in your liver have the ability to become hepatocytes, actual liver metabolizing cells, but they can also become biliary tract cells. They can also become blood vessel cells. They can also become cells that are support cells. And so that they choose their fate based upon demand.
Yes.
And that's really critical. We actually know now that a lot of that choice, a lot of that fate choice occurs directed by where the cell is. And so we know that every tissue in our body is a combination of a structure, a template occupied by cells. That template provides chemical signals that tells the cell where it is. I often say it's like you walk into the mall and you look at the map and it says you are here, and now you know how to go find, Abercrombie and Fitch or whatnot. The truth of the matter is the same thing happens in the body and in our tissues. The different cells, the different stem cells on the tissue know where they are, and they specialize in an appropriate way. That's why if I inject stem cells into your bloodstream and they get to the liver, but they don't yet become liver cells, they don't eventually make a mistake and become a brain cell. That's that specialized maturation process is very much orchestrated by the environment.
Did you see the movie Oppenheimer? If you did you know that besides building the atomic bomb at Los Alamos National Labs, that they spent billions on biodefense weapons, the ability to accurately detect viruses and microbes by reading their RNA? Well, a company called Viome exclusively licensed the technology from Los Alamos Labs to build a platform that can measure your microbiome and the RNA in your blood. Now, Viome has a product that I've personally used for years called Full Body Intelligence, which collects a few drops of your blood, spit, and stool and can tell you so much about your health. They've tested over 700,000 individuals and used their AI models to deliver members critical health guidance, like what foods you should eat, what foods you shouldn't eat, as well as your supplements and probiotics, your biological age, and other deep health insights. And the results of their recommendations are nothing short of stellar. As reported in the American Journal of Lifestyle Medicine, after just 6 months of following Viome's recommendations, members reported the following: a 36% reduction in depression, a 40% reduction in anxiety, a 30% reduction in diabetes, and a 48% reduction in IBS. Listen, I've been using Viome for 3 years. I know that my oral and gut health is one of my highest priorities. Best of all, Viome is affordable, which is part of my mission to democratize health. If you want to join me on this journey, go to viome.com/Peter. I've asked Naveen Jain, a friend of mine who's the founder and CEO of Viome, to give my listeners a special discount. You'll find it at viome.com/Peter. So I think one thing that's important to discuss here is what happens as you age to your stem cells, and I would call, stem cell exhaustion. And again, this is research that you've done and you brought to the industry here, is how many stem cells you begin with as a newborn and where do you end up at the end of life. And it's like another version of your mansion story is, imagine you built a giant mansion. I've heard you present this. And in the beginning, your mansion has a whole bunch of repairmen and it has perfect instructions. And as the repairmen are keeping things going, following the instructions, the mansion stays in great shape. But eventually the repairmen or women start to die off, and the population of people being able to repair the mansion begins to degrade and eventually fall away. And the instruction set begins to blur and tatter. Your ability to keep the mansion in good structural health disappears. And you're getting that as well with stem cells. So talk to us about the change in populations.
So every stem cell has I always say, every stem cell retains the fully transcribable genome. What that means is we know that our biological software is in our DNA, in our genetic material, and that software is used to make all of the necessary chemicals and proteins and signaling molecules that drive the functionality of every cell in our body. And those functions differ based upon the organ or tissue. Liver cells have part of their genome dedicated to liver functions, and in the process of becoming a liver cell, part of the genetic material gets silenced so that it's very efficient in what it does. The stem cell, in contrast, retains all that versatility, the ability to read the whole genome. You know that when we first started to build our interest in this field, we created a company called Human Longevity. And Human Longevity was dedicated to interrogating the genome of long-lived people to better understand what might be a hallmark of long life. Well, if you remember, our former partner, Craig Venter, the first scientist to sequence the human genome, always spoke about DNA as biological software. And I always spoke of stem cells as the mini computer, that the software resided in the nucleus, and all of the reading and writing of that software took place in the cell, the cytoplasm of the cell, and the surface of the cell acted like a keyboard. And so if you think of it in that model, then what a stem cell is that is so valuable to us is it's like a perfect, uncorrupted reboot disk, master boot disk, that as long as you keep it in good condition, anytime your software gets damaged, and your software gets damaged by mutation, it gets damaged by exhaustion, it gets damaged by chemical adulterants, anytime that happens, if you can reinstall the software with this master boot disk, you can get back to a state of high health, high functionality.
By the way, anybody under 35 may not know what a boot disk is, but it was what you used to get with your computer that would boot up the computer and install the the initialization of your disk drive. Anyway, but the analogy still holds. So one of the things you mentioned to me is like between birth and death, you get something like 100 to 1,000-fold reduction in the number of stem cells in each of the tissues of your body. Is that true?
We know that a hallmark of youth is a very abundant, to use a term that's important, an abundant, healthy supply of stem cells. So if you look at one organ system, let's look at bone marrow, okay? And people know bone marrow makes the blood cells, the red blood cells, the white blood cells, the platelets. Bone marrow is filled with stem cells that do all that. Mm-hmm. At the top, early in life, early after birth, if you were to measure the number of stem cells in the bone marrow of a 8-week-old, about 1 in 20 to 30,000 cells in the bone marrow of a newborn is a stem cell. Over your lifetime, that number declines. It declines exponentially. So if you look at the bone marrow of an 80-year-old, it's 1 in 20 to 30 million cells.
1,000-fold reduction.
1,000-fold reduction. Now, it should be obvious to everybody that the more stem cells you have, the more you're able to respond to the need for repair and renovation. And as you get older, if it's harder to find a stem cell to do that work, you're not going to repair back to the same state of function and health. So think about it as you're using up your toolkit supplies.
You know, you've talked about this with the stem cells. Again, I love the term, it's a regenerative engine of your body. And that we have the ability now to just not accept that, right? So people who've heard this conversation on these podcasts with me about longevity know that we are in peak condition typically in our late 20s, like 27 to 30 years old. And it's a slow decline of loss of muscle, a loss of immune function, a loss of hormonal balance, and very significantly, a loss of stem cell capacity. And you can accept that and accept your fate, or you can fight against it. And I think one of the things that you have been leading the charge on, and I remember the first conversation you and I had about it, and I was like, oh my God, this is incredibly exciting, is the idea of stem cell supplementation, and the idea of being able to store your own stem cells. We'll get to that, but also to utilize placental stem cells.
Right.
So I want to talk about and use those to augment your stem cell populations and even augment your immune system. And so not accepting what is and saying, no, I want to restore my level of regenerative capability in my body. And that is the vision. And I feel confident for the work that you've done and others have done, that it is definitively possible. Yeah. And we'll get to that.
Why I got into this field.
Yeah, that's why you got into the field, right? And I want to talk about how you got into this field. But before that, let's talk about the different types and origins of stem cells, because there are lots of different types of stem cells. Right. And let's define them, their utility. When people say they got stem cells, where might they have got them from? Yeah, so if you don't mind, walk me through that.
So there's two important concepts you just touched on. One is that if we could augment or supplement our reserve of stem cells with a supply of stem cells out there, that's good. That's a good thing, right? We already know, it's well accepted in the scientific community, that a hallmark of aging is exhausting your stem cell supply. And it makes sense, right? It's intuitively logical to everybody. If my body repairs itself by stem cells and I run out of stem cells, I stop repairing myself, right? It's obvious to everybody. The first concept is that if you can supplement or augment your stem cells, that's a good thing. Mm-hmm. Now, 30 years ago, I said, well, wait a second. Since I know I can get stem cells from the leftovers of a healthy pregnancy, and it's easy for me to isolate those cells and put them into a state of suspended animation by cryopreserving them, freezing them at ultra low temperatures. If I need them later in life, can I just thaw them out and use them? And the concept there is true. You can do that. And that's the whole foundation for the newborn cell banking industry, which has been around for over 30 years. The second concept you have... Before we go there, can I just mention, you mentioned the leftovers of pregnancy. So just to be clear about this, for folks to get an image here, when an embryo is in utero, it is getting a supply of cells from the placenta, right? Which, I use the term, and thank you for crediting me for it, the placenta is a 3D printer that manufactures the baby. Right. Right. I love that concept.
And so the placenta has like all of the stem cells in it, the original boot disc, which is your term I utilize. And so you normally in labor and delivery room pay for your expelled placenta to be burned in the incinerator. Right. And you pay a fee there.
It's a waste material. Waste. Yeah.
But it's crazy because it's like one of the most powerful materials. It's like throwing away an extra set of organs for your child. It
offended me. It offended me to see this beautiful tissue being discarded. And by the way, people say, Bob, why is a neurosurgeon, chasing placentas? They thought I lost my mind. The reality is that I recognized that this was a pristine tissue, right? It's the age of the newborn. It has structure, function, and cellular content that is about as good as it's going to get. And most importantly, these are as you said, these are just paid to be disposed of when they're readily available. All you needed to do was come up with an industrialized process to utilize those materials and cells. So to your point, the placenta is an ideal place to get leftover cells. Yeah. It all started when we recognized that you could find bone marrow and blood stem cells left over in the circulating blood of the umbilical cord at the time of birth. And, you clamp the cord, you cut the cord, baby in a little piece of cord goes one place, the placenta and the umbilical cord goes into the wastebasket. My concept at the beginning was, why let it go into the biohazard wastebasket? Collect it, process it, and use the benefits of what we know about cryopreserving cells to store them away forever. And so that's that.
Yeah, I want to break that down 1 second because first of all, one of the divisions that Celularity has is LifeBank USA, and a lot of folks might have heard of cord blood banking, where you actually take the cord blood, which has hepatocyte stem cells, right?
Hematopoietic
stem cells. Yes, thank you. Blood stem cells, and that has always been the biggest industry, but it's missing the point because what you really want is the stem cells that make up all of the tissues of the body, and that's in the placenta. So LifeBank USA is someplace where if someone listening is having a baby, like my two 13-year-old boys now, 13 years ago, we stored their placentas, the cells out of the placenta with you. You have a room full of cryo freezers, and I'm saying, Bob, where are my kids stored? I go over and say hello to their stem cells, and now 13 years later, my niece Christina is having her baby today, and they have a LifeBank USA collection kit. They'll collect the placenta and some cord blood, and that gets shipped to you and then processed, and then her newborn will be on. I think it's a moral obligation for any parent to save that for their child.
I couldn't agree with you more. Look, 30 some odd years ago, and I give my older daughter Alex credit for this, right? When I was a young surgeon and she was in utero, and I went down to see the first trimester ultrasound. I tell you this story all the time. And I looked at her little peanut-sized embryo, but the placenta was already a big organ. I said to myself, well, wait a second. In medical school, we were taught that the placenta was a vascular connection between the mom and the developing baby. As an engineer, when I looked at that, it didn't make sense to me because if she was just a peanut size and the placenta was already a big organ, it suggested to me that the placenta played a role in making that embryo become a fetus and beyond, right? It was participating like a 3D printer in printing the baby. And you said something very important, which is, if you look at an embryo, there just aren't enough cells in an embryo, even at the maximum rate of division, to build a baby in 9 months. Some of the additional cells necessary to build that baby have to come from somewhere, and they come from the supply depot, and the supply depot is the placenta.
Yeah. So I just want people to recognize that the placenta is a valuable asset to a family.
But listen, we're talking to government leaders in certain jurisdictions. This should almost be a medical imperative, because if you have this supply of repair and starting material, you may in fact be able to prevent and interrupt disease progress. And we're in the era of cellular engineering. You can fix things. If I have your stem cells from your placenta stored, that's the perfect blank canvas to subject to all these new ways of editing the genome, making you a better, superior, healthy individual, creating immune cells that now target your disease, fixing your immune cells that give you autoimmunity. I mean, all these things are possible if you have the raw material supply. And you remember, almost 20 years ago, I did that little skunk works experiment where I collected stem cells from the placenta from newborn rats, processed them and stored them, and gave those rats back their stem cells as they aged, and the animals lived 40% longer than the untreated animals, right? So you and I both know this is a potential cornerstone of the technologies that will allow us to live healthier, longer lives.
Everybody, I want to take a short break from our episode to talk about a company that's very important to me and could actually save your life or the life of someone that you love. The company is called Fountain Life, and it's a company I started years ago with Tony Robbins and a group of very talented physicians. You know, most of us don't actually know what's going on inside our body. We're all optimists. Until that day when you have a pain in your side, you go to the physician in the emergency room and they say, listen, I'm sorry to tell you this, but you have this stage 3 or 4 going on. And, you know, it didn't start that morning. It probably was a problem that's been going on for some time. But because we never look, we don't find out. So what we built at Fountain Life was the world's most advanced diagnostic centers. We have 4 across the US today, and we're building 20 around the world. These centers give you a full body MRI, a brain vasculature, an AI-enabled coronary CT looking for soft plaque, a DEXA scan, a GRAIL blood cancer test, a full executive blood workup. It's the most advanced workup you'll ever receive. 150 gigabytes of data that then go to our AIs and our physicians to find any disease at the very beginning when it's solvable. You're going to find out eventually. You might as well find out when you can take action. Fountain Life also has an entire side of therapeutics. We look around the world for the most advanced therapeutics that can add 10, 20 healthy years to your life, and we provide them to you at our centers. So if this is of interest to you, please go and check it out. Go to fountainlife.com/Peter. When Tony and I wrote our New York Times bestseller, Life Force, we had 30,000 people who reached out to us for Fountain Life memberships. If you go to fountainlife.com/Peter, we'll put you to the top of the list. Really, it's something that is, for me, one of the most important things I offer my entire family, the CEOs of my companies, my friends. It's a chance to really add decades onto our healthy lifespans. Go to fountainlife.com/Peter. It's one of the most important things I can offer to you as one of my listeners. All right, let's go back to our episode. I love this. Okay, so I want people to realize that you can get stem cells from the placenta. Some companies will give you stem cells from the umbilical cord. And then
the umbilical cord, the cord blood, right?
And cord blood. But there's a few other options for where people get stem cells. Can you run through those?
Yeah. So in an effort to make stem cells available to people, technologies like induced pluripotency was created. Yamanaka won the Nobel Prize for figuring out how to take one of your mature specialized cells and reprogramming it so it acts like a stem cell. That was because not everybody had their placenta stored at birth or their cells stored early in life. But I'm here to tell you, as phenomenal and exciting as that technology is, it's going through a lot of acrobatics to make an adult cell behave like a placental cell. And even though you might turn on pluripotency, you don't change the age of that cell. And there are other parts of the cell besides the parts that get reprogrammed that age, mitochondria age, cell membranes age, et cetera. And so I am here to say the placenta is the ideal alternative, even if you don't have your own cells banked. And that was one of our seminal breakthroughs and discoveries early on, which is that, lo and behold, aside from the fact that the placenta is the stem cell factory, the cells in the placenta are nature's universal donor cells. And you've heard me talk about this, Peter.
Absolutely.
So I often say, mom and dad contribute 50% each of the DNA of their offspring. So the fetus and its placenta growing inside mom's womb is only a 50-50 match to mom. Yet she doesn't reject it and it doesn't reject her. That's pretty cool, right? Well, what about surrogate pregnancy? In surrogate pregnancy, mom's not even related to the placenta or the fetus that is being developed, and she doesn't reject it. So it's proven by nature, and I often say mammalian evolution could not have occurred without the placenta becoming a perfect universal donor tissue able to tolerate the existence of a different phenotype and different serotype. And so that's the elegance of having the placenta, is I can use those cells in a completely unrelated recipient.
So there is those, and then let's talk about so there's autologous and allogeneic. Can you explain those terms?
Let me explain those concepts, right? Yeah. Autologous means the cells come from you.
Auto self, right?
You can get stem cells from your blood, from your bone marrow, from your adipose tissue. There's lots of places you can get stem cells that are your own. Or you can take a mature cell, like a fibroblast from your skin. You can subject it to Yamanaka's methodology, and you can induce pluripotency. And that's now a stem cell that has the versatile ability to divide, et cetera. So those are two of the types. You can get stem cells from parasites, from the not parasites, but pericytes. These are the cells that line blood vessels. Okay. You can get stem cells from bone marrow, from peripheral blood that you mobilize the stem cells from bone marrow into. And you can get stem cells from virtually any tissue if you're willing to take a scalpel to that tissue. Nice. In contrast, there's no risk to collecting cells from the placenta. It is waste material. The baby's already born and off enjoying its life when the placenta is expelled, goes into the wastebasket, comes to our laboratories, and gets processed. And from one placenta, we can produce tremendous quantities of stem cells.
And then allogeneic refers to?
Allogeneic means the cells come from somebody else, and in those cases you have to if they're not derived from an allogeneic placenta, you have to make certain that there's no immunologic conflict between the donor and the recipient.
Yes.
Now, allogeneic therapy is really the hallmark of efforts to create off-the-shelf cell therapy products. Autologous cell therapy products, like, for example, immunotherapy for cancer, means you got to collect your own cells, process them, and then get them back at some point in the future.
So, Bob, there's been a lot of controversy over the years about stem cells, a lot of fear and concerns. Where did that originate from? What have people heard about that's caused this concern that you can assuage their fears about?
Well, you remember from medical school, embryology is the study of how we originate from a single cell into an embryo and then form a fully functioning human being. It was that original work that led to scientists looking at the leftover embryos from in vitro fertilization program. These are the ones that are going to be discarded because they're not used, to see if they could isolate some cells and then grow them up into a population of cells that could potentially be used in therapy. That means you have to destroy an embryo. And early on, the controversy that erupted was that at the stage of when you can isolate stem cells, that embryo still has the potential to go on to become a human being. Does it constitute a life that you should not be allowed to compromise or sacrifice? That was the fundamental origins of the controversy. Then, because you can get stem cells from a few stages down in development from the fetus, and as a byproduct of abortion, scientists showed you could isolate stem cells from the leftovers of the abortion process. These put a very, very significant part of the community under great concern that there could be a very perverted incentive to create human life in the form of an embryo or a fetus just to destroy it.
Yeah.
And so the pro-life, pro-choice debate was the foundation upon which the controversy around stem cells really emerged. And I'm very happy to say that our discovery of the placenta as an ideal alternative to that, and by the way, the placenta is pro-life and pro-choice, right?
Yes.
So there is no objection to using the leftovers of a full-term healthy pregnancy to derive stem cells It's abundantly available. The economics are better. And if I can get a dozen cells from an embryo, I'm lucky. I can get 1 billion cells easily, multi-billion cells from a placenta. So the sheer logistical convenience of using the placenta, all of the characteristics I'm telling you about, the immune tolerating ability of the placenta, the universal donor characteristics, all that make the placenta just an ideal source to obviate the need to use for embryos or fetal material.
Yeah. So I just want folks to understand the original controversy and concerns originated from the idea of using embryonic stem cells from an abortion, from a fetus. And today, the stem cell industry under Bob's leadership and others has matured far past that, where we can now identify, we can give you back your own stem cells. We can extract them, we can concentrate them, we can manipulate them in a number of ways. We should talk about that again, because that's not yet FDA approved. Hopefully under a new administration, it will be. Or we can give you placental or umbilical cord stem cells, allogeneic from somebody else, which are safe and have been done. How many total allogeneic stem cells treatments do you think, your best guess, have been done around the world?
Oh, millions.
Millions. Okay.
Many.
So, yeah. So, I mean, this is not like a wild frontier of an idea someone came up with in their garage and is trying on you.
Exactly. Here's bad news travels fast. Okay.
Yes.
If cell therapy, and I make this argument all the time, and I sometimes pit myself against others in the field. If bad things happen from cell therapy, if bad things happen from using stem cells in treating different diseases, the bad news would travel fast. Now, there have been a few isolated situations where people with irreversible, hopeless diseases sought cell therapy from, let's admit it, from certain unscrupulous, opportunistic providers.
And as a therapy of last resort for them, because they're trying everything.
That's right. And listen, I have such a lot of respect for the FDA. The current head of the division of the FDA that oversees cell therapy, Dr. Peter Marks, has an incredibly complicated, difficult job, and he has done an amazing job in focusing attention. He wants to see these therapies approved. He wants to make sure they're approved the right way, and he wants to make sure that there's never a shortcut in producing the products. I salute that completely, and I celebrate that completely.
Yeah, I mean, it's important for people to know there are a lot of mom and pop shops around the country that will promise you stem cell treatments, and you need to really understand the origin, their experience, because they're not legally doing it. Let's begin with that.
They're operating in the gray zone between a fully developed, regulated therapeutic that meets the high standards of safety and efficacy prescribed by the FDA. They try and go around that. Groups like ours do the hard work of taking these candidate therapies through the process of clinical development, clinical trials, where we are controlling the treatments, we're controlling the analysis, we're controlling the manufacturing, because that's the best way to ensure that no one takes a shortcut to transforming the way a disease is treated.
Yeah.
But I'll tell you this much: I do believe that there is room here. I do believe there's room here, and I'm in the dialogue. There's room to be more receptive and more open to accelerating the process of review for cell therapies, and also, and this is a little pet peeve of mine, taking advantage of the long safety track record of cell therapy and allowing some of the evaluation to take place on the run. In other words, have some form of a provisional approval process where cell therapies that meet a high standard for safety, are allowed to be tried, particularly in some of these hopeless diseases. Let's talk about ALS, right? Lou Gehrig's disease. Nothing works there. You're going to die if you have ALS. I don't see a downside to using a number of cell therapy products that meet that safety standard, and then rigorously collecting the data. It'll actually do us a big favor to open up the number of programs where we're very rigorous about collecting data in order to make better decisions about what is acceptable or not acceptable to be moved into the therapeutic armamentarium of doctors.
Let's talk about the social proof here. There have been a number of success stories, right? Again, I mentioned the opening of the Life Force book, where Tony calls me up and he goes, "Man, I've just had the worst snowboarding accident, and I have just massively injured my shoulder. What should I do?" And I say, "Tony, you need to talk to Bob Hariri." He says, "Okay." I say, "Bob is, for me, my world's expert in stem cells. And I think, these types of injuries could benefit." And he called you. And at that time, we were both recommending utilizing the Panama Stem Cell Institute. I think now we've seen the emergence of down in Costa Rica, RMI, the Regenerative Medicine Institute, under Vince Giampapa, and most everybody that we recommend who needs this level of allogeneic stem cells goes down there until we have them operational here in the U.S., perhaps at Fountain. But take the story from there. And I'd like to hear some other success stories that you could share.
So Tony is an example. And by the way, you and I fall into the same category. We're at that age where we break stuff, we tear stuff, and our body makes a great attempt to mobilize our own stem cell populations and get them to the injury to participate in the repair. But sometimes it's too little, too late. And so in Tony's case, and let's face it, Tony's like a professional athlete times 10, right? Yeah. Aside from being 6'8" and 270 pounds, in a physical specimen, he taxes his body to the absolute limits, right? I mean, you and I are blown away when we're with him at his house, and he's got basically a professional gymnasium where he works out like a maniac. When he tore up his shoulders, tore up his hips, and hurt his back, he either had to go for prosthetic replacement type surgery, or he had to attempt to turn up the regenerative power of his body. And the only way to do it, because his own cells were either too limited, too little, or too late, was to augment it with newborn cells. And we all know, as is covered in the book, he had a life-changing response. I have had 30 some odd orthopedic procedures in my life. My shoulders have been torn up. I have no rotator cuffs. The only thing that keeps me active is I have range of motion and I can do stuff, is I've used cell therapy and the byproducts of cells to stimulate the repair process and tamp down the inflammation that causes the functional decline.
Yeah, I'll give a quick aside there for myself. I ran an experiment, not on purpose, but in retrospect, where I had the same surgeon do the exact same surgery on my two shoulders about 10 years apart. And I had a bone spur and a rotator cuff injury and pain while I couldn't sleep. And on one side, my left side originally, that had no regenerative medicine impact. On the right side, after the surgery, I had 2 injections of exosomes. And I was 10 years older, and my recovery time was a fraction, and my pain was a fraction of what it was on my other shoulder. Right. Now, listen, this is subjective, but it was like, wow, that was different.
Yeah. Listen, me too. I mean, when I tore my shoulder up and I couldn't sleep, the pain was unbearable. I couldn't move it. I couldn't load the bicep. When I went and got first placental cells injected into one shoulder, and within a matter of days had considerable reduction in pain and improvement in function. And then when I tore the other one up, I used exosomes just like you did, and got very noticeable, quantifiable relief. And most importantly, it turned off the processes that would lead to long-term dysfunction, like scarring.
Yes, scarring.
Like changes to bone and cartilage and all that. So look, we're proof in practice that this stuff actually does work. And by the way, people wouldn't be seeking these therapies if there wasn't enough evidence from other people as well as growing evidence in individuals themselves that this stuff actually is an alternative to other forms of therapy.
Bob, two things. One, first off, can you explain what an exosome is?
Yep.
And secondly, why haven't the clinical trials been done yet that allow the FDA to say, yea, verily, this is safe and efficacious?
Well, first of all, let me say this. There have been a lot of clinical trials that I don't necessarily agree with how the data has been analyzed and interpreted. I believe the bar for proving efficacy in cell therapies has been unusually high. The best example is in the treatment of heart failure after myocardial infarction, where again, once you damage your heart, it's damaged, and you can't fix that unless there is a regenerative event that's taking place. So I think the bar has been very, very high. I think we're using 20th century methodology to evaluate clinical trials in cell therapy. That's a 21st century technology. And so the metrics have to be reevaluated. And I think the time course of looking for changes has to be lengthened. And by the way, you know what the rate limiter for clinical trials is? It's
money.
The time exactly. It's the time and cost of the trial. And so if you need to have a lens that's looking at the results of cell therapy that's 6 months, a year, 2 years down the road, and is also 6 months, a year, 2 years, and over multiple treatments down the road, it becomes prohibitive for the companies who are in this field to do those studies. Listen, there are no big companies doing stem cell clinical development work. They're all developmental stage biotechs.
Yeah.
Developmental stage biotechs can do only as much as the capital they raise to do those studies. So the odds are against getting to the point that you're going to meet those very high regulatory standards. But I do believe, in partnership with the regulators, we have to say, look, let's agree that no doubt quality products that are assured to be made under the quality systems of GMP and go through the right kind of release specification testing and so on, with the right kind of evidence of safety, acute and even long-term safety, should be allowed to be introduced into the treatment regimens. Because, by the way, here's the other thing. There's probably a very high likelihood that cell therapy, in combination with some other elements of conventional therapy, is where you get the real return on investment, okay? The real benefits patients need. We're not doing that because the regulatory system isn't designed to look at things that way.
Yep.
But I personally think we're at a stage right now where regulators can be more permissive, allow for real world evaluation of the long-term benefits of cell therapy in products that meet a high quality standard and that have the fundamental assurance of safety, acute safety, that is necessary to get into the clinic. If we did that, we could build the database. And by the way, we live in the world of AI and machine learning. What does AI and machine learning need? It needs big data sets.
Yep.
Not 10 patients, not 100 patients, but 10,000 patients worth.
So if Bobby Kennedy is confirmed, is he pro stem cells and pro regenerative medicine?
So, I know that there's a great deal of concern. Bobby Kennedy is a very outspoken proponent of looking at therapeutics differently than the conventional views out there. But he is very much a proponent of the U.S. having to advance and innovate in therapeutics, among which cell therapy is one of the categories. And I do believe that he will find the way to work with partners in the FDA and NIH and so on that will be willing to be far more inclusive and receptive to development models where you have a longer lens on the patient's results, that you are looking at a range of different outcome variables, and that you're testing in the context of finding ways for these therapeutics to fit the conventional treatment regimen. And that may include using with drugs and other components and so on and so forth.
Real quick, I've been getting the most unusual compliments lately on my skin. The truth is, I use a lotion every morning and every night religiously called OneSkin. It was developed by 4 PhD women who determined a 10 amino acid sequence that is a senolytic that kills senile cells in your skin. And this literally reverses the age of your skin. And I think it's one of the most incredible products. I use it all the time. If you're interested, check out the show notes. I've asked my team to link to it below. All right, let's get back to the episode. All right, exosomes. Give us a 101 on exosomes real quick. People have heard about them. They've heard about them treating for your skin, for your hair, for all kinds of things.
So an exosome, think of an exosome as a packet of materials that include signaling molecules, growth factors, microRNAs, all the ways that cells communicate with each other chemically gets packaged in what's called an extracellular vesicle. It's a membrane-wrapped little delivery package, and that contains important molecules that can be anti-inflammatory, pro-regenerative, and even help stimulate the expression of certain genes in an individual's genome. And the way they work is that they are released by cells, they can be processed and collected in a manufacturing system, and then when administered to an individual, because they're membrane bound, they fuse with the membrane of a person's cells and deliver that information into the cell. It's like a special delivery package of a anti-inflammatory growth factor or a regenerative peptide. That's the way to think about it.
Okay. So I want to continue. Tony is a great example. You and I have both benefited here. What are some of the other stories that you've been involved in or seen in this stem cell success story, just for folks to have some sense of the broadness here?
Well, people would be surprised to know that many of our most celebrated theater and movie celebrities who are aging, but are still facing the demands of a very active physical life and so on and so forth, have sought out cell therapy in one form or another. Some go to clinics in Europe. Le Prairie, for example, has been a clinic that has been delivering cell therapy. It is not human cell therapy. It's cell therapy derived from other species, but they know that the benefits for anti-aging, for preservation of performance, for aesthetic benefits are there. So people have sought it out. I have taken, a number of well-known people to different clinical environments in Central to South America, even in Mexico, Bahamas, and these folks have seen very tangible improvements in a particular need they have. And the most common, I'll tell you right now, the most common thing people go to is for joint problems, right?
Yeah.
Arthritis, and we're very, very active in advancing these approaches to treat something that plagues us all as we age, which is the loss of muscle mass. So sarcopenia is one of my...
I think let's talk about that, because you pointed out to me the Karolinska studies that muscle mass and longevity are highly correlated. I worked diligently on putting on 10 pounds of muscle mass last year, really through your inspiration and encouragement. So please talk to me about that.
So people don't recognize how important skeletal muscle is. It's kind of like a forgotten organ. People don't think of it as an organ, right? But muscle makes up 50% of the wet body mass of the average individual, and that means it's the largest synthetic organ in the body. The cells in your muscle make up a whole array of chemicals called the myokinome, and those chemicals influence every cell and tissue in your body, including your brain. And so that's why exercise and getting those muscles working actually is good for your brain health, for your immune health, etc. Now, in addition, muscle is the largest venous capacitance organ, which means it's got the largest network of small blood vessels low flow blood vessels, low pressure blood vessels, and that's where a lot of our stem and immune cells take up residence. They sequester there, laying in wait to be called upon to traffic and do their job. Now, you probably remember 20 years ago, I said that muscle is the forgotten frontier for the therapeutics and pharmaceutical industry. And if you remember, I got very active at finding ways to modulate myostatin, a protein that is designed to control how much lean muscle mass you make. And I saw that as an opportunity to enhance muscle quality and growth with this blockade of this negative peptide. And we actually were able to do that with nutritional products. And there's even a number of pharmaceutical approaches as well. It turns out that this is incredibly important because of the study you just quoted. The Karolinska Institute, which is the Mayo Clinic of Europe, okay? The Karolinska Institute followed 9,000 men for 25 years. And what they found was that men who maintained healthy lean muscle mass and strength, even if their body mass index was considered to be obese, had a higher resistance to dying from cancer or heart disease than any other indicator. So muscle mass is a better predictor of longevity and health than body mass index, weight, any of those metabolic markers.
Yeah, I love that. For me, I keep on saying any company that will increase muscle mass is a company I want to look at investing in. Bob, you and I are co-founders along with Tony Robbins and Bob and Bill Kapp of Fountain Life, and Fountain Life, has done an amazing job in the diagnostic side. Right, we upload about 200 gigabytes of data through full body and brain MRI, DEXA scan, coronary CT with an AI overlay, low dose lung CT, all the blood biomarkers, your full genomics, metabolomics, microbiome, a lot. And that's been great. And the goal is, can we answer two questions? Is there anything going on inside you right now you need to know about? And what's likely to happen to you that we can prevent by optimizing you? But that's half of the objective. All right. It's finding disease at the earliest stage when it's most treatable. You and I have always had the vision. We had this back in HLI, but it didn't materialize there. So it's materializing in Fountain, that the diagnostics are important, but the therapeutics are as important. So how do we deliver our Fountain Life members the highest reward, lowest risk therapeutics, and really search the world for those and then deliver them at the centers? So I want to talk a little bit about that. I want to get your thoughts, because I think we're just at the brink of a lot of these very exciting longevity therapeutics. I mean, that's the goal, is to restore function. And you've taught me it's, are you thinking clearly? Are you looking good? Are you moving well? Right? That's what people want through their 99th birthday. So the question is, are we going to be able to, deliver some of these therapeutics, stem cells, exosomes, and other things through Fountain Life? What's your vision there?
Well, listen, you and I have talked for a long time about what's meaningful. The concept of anti-aging and longevity has been a bit perverted over the years, right? It was seemed to be kind of the folly of the wealthy, and not necessarily, there weren't in some cases morally justifiable reasons for wanting to live to 150 and so on and so forth. When I was a kid, there was a TV show called The Immortal, and I used to love that show. You might remember it. Where the guy had blood, he had blood to live forever, and so he was hunted by the billionaires who wanted to, take his blood, etc. So, look, here's the bottom line.
Sure.
Meaningful long life requires preservation of performance, and I always say it's about high performance mobility, like you said, high performance cognition, you got to think, high performance immunity, and youthful aesthetics. Those four things, in my mind, constitute meaningful long life. Those are all achievable using many different approaches: nutrition, exercise, etc., maintaining muscle mass. But it is the perfect target for the regenerative therapies available through cellular medicine. And when you and I first built Human Longevity, and then we decided that we were going to now perfect it in Fountain Life, our objective was to do two things. We wanted to use a proactive approach in healthcare. Like you said, identify and eradicate causes of premature death. That's the obvious low-hanging fruit. You know, and I know, life expectancy is an average lifespan of everybody, which means that if it's 80, if it's 78 or 80 years of age, and we know people live to 95, 100, et cetera, a lot of people are dying early. So step number one, eradicate causes of premature death. What are the causes of premature death that get away from us? They're cardiovascular, they're cancer, okay? Mm-hmm. The cardiovascular ones are the explosive things, like aneurysmal ruptures, right? Like cardiovascular failure due to electrical issues that cause sudden cardiac death. Undiagnosed cancers that before you know it, and when you first find out you have them, they're so advanced they can't be managed. So anything that can identify stuff early enough to be intervened with, that's a principal target of Fountain Life. And we've already proven it works, right? We know it works.
We've saved hundreds and hundreds of lives.
Hundreds of lives. And we're saving lives in the first community who are making access to this, which are the informed, educated, affluent people who are already getting the best health care. Look, how many people do you and I both know, people we know, who have religiously pursued healthcare with the best physicians, and they have a clean bill of health. They come into Fountain Life, and we identify
Sam Nazarian, who's made this public, who's one of our new partners building out centers around the world. I said, listen, Sam, come down and see the Fountain Life facility. I was taking him through to meet Richard Branson at Necker Island, and we stopped through, and he went through an upload. He and his wife. And this is a guy who has built the greatest hotels in the world. He is, I don't know how close he is or how much of a billionaire or multi-billionaire he is, but best physicians. And he comes through, and at the end of this upload, we find 2 brain aneurysms. And he's in surgery a week later. And he's cured now, but those were ticking time bombs. And it's like, really? It's like your other doctors didn't find these that have been around for so long? That's insane.
Yeah. I mean, look, the truth of the matter is we now have at our disposal high-resolution imaging technology, which the cost has come down. With the advent of AI and so on and so forth, the ability to interpret is going to improve. And aneurysms are relatively easy to spot as long as you have the imaging study. Yeah. And so if for a relatively modest amount of money, you can ensure yourself that you don't have one of these ticking time bombs. It's worth it, right? Likewise, if the same imaging study can tell you whether or not you have a smoldering malignancy in your thyroid or in your kidney, your
pancreas, your brain,
How many of our friends were in perfect health, living the dream, and they found out that they had a subclinical kidney cancer, which fortunately is easily addressed when you catch things early. By the way, this is not new. The American Cancer Society said 30, 40 years ago, early detection is the key to survival in cancer, right? Yep. So the faster you find something, the more options you have to treat it. And excisional procedures for cancer, we know, are life-saving. And so just what Fountain Life does in identifying and eradicating these premature causes of death is enormous. But more importantly, and this is our aviation background is coming out. What have I said to you for 25, since we've known each other? I said, the reason we fly airplanes that can be 20 years old is because we go through a process that was developed by engineers, and that's why I like having that engineering background, where because of root cause analysis, we figure out what is the source of a mission critical failure, And if it's a mechanical component, you inspect and replace at 50% lifespan so that you never have a mission critical failure. And you learn over time what those are. We already know what the mission critical failures are in biology.
Yeah.
We can use the same proactive approach, and we can, I believe, prevent the tremendous cost of care. Look, we identify a kidney cancer in somebody preclinically and treat them. You have saved potentially millions of dollars in care that they need, right? Aside from the misery.
It needs to be said as well. We have a couple of friends in Dean Kamen and Martine Rothblatt who are doing something extraordinarily magical. And you've spoken about this, and you did a lot of the early work as well, which is regrowing organs or remanufacturing organs, right? Yeah. Going from a stem cell, or even going from a skin cell to a pluripotent stem cell with the Yamanaka factors, growing up billions of those cells, differentiating them into heart, liver, lung, kidney, and remanufacturing a brand new organ with your own DNA and your own surface antigens. It's the reason that airplanes and Ford Model Ts 100 years ago are still operating today, is you can replace the parts.
I often tell families who are thinking about banking their kids' stem cells at birth, I said, look, if your baby was born with an extra set of kidneys, an extra set of lungs, and an extra heart, would you throw them out at birth? And that's what you actually have when you have a supply of stem cells that can be used in these purposes. And by the way, Peter, I was the first guy to actually take an organ.
Yeah, tell this story, but I love it.
So over 20 years ago, I was the first guy to take a solid organ and remove all the living cells from the organ.
What organ did you choose?
We originally started with the placenta, but we did it with hearts as well.
Yeah.
Basically, wash out all of the cells, the living cells in that organ, leave behind a beautiful three-dimensional architecture template of the organ, and then inject.
Can I 1 second just to give people a visual here? If you have a heart and you use a detergent, right? This is a detergent. It actually will decellularize the heart. In other words, the cells are falling away.
Right.
But what's left is, and it's hard to imagine this, but there is a massive structure. Oh, it's collagen structure, right?
It's a combination of different structural proteins, but it is basically the architecture of the organ.
So it looks like a ghost organ there. It's
translucent. They're beautiful. They look like a glass cast of the actual organ, and it has all the blood vessel structures in place. It has all the mechanical structures, the valves, and so on and so forth. But when I first did this with the placenta, I basically washed out all of the cells of the placenta, and then I could repopulate the organ any way I wanted to based on the stem cells I implanted into it. So my original invention, my original patent, which was entitled "The Renovation and Repopulation of Cadaveric Organs and Tissue Matrices with Stem Cells," was the roadmap for what's being done now by Martine and Dean, where they're basically using that approach to create a repopulatable template, and then using cells that are either fate-driven cells from iPSCs or they're donor cells. And here's the really cool thing. If you inject pluripotent, versatile stem cells into a perfectly preserved matrix of a tissue, they actually know where they are and they differentiate appropriately.
GPS locations.
GPS.
Yeah, amazing. Buddy, I want to wrap with just a quick conversation about cellularity. And people who look up your bio, and you are one of the most brilliant scientists, entrepreneur, engineers that I know, and I love you as an older brother. I'm always thankful that the fact that you're a couple of years older than me, so that you're the one that's going to be pushing harder than I am on the regenerative medicine side. So you used to run the cellular medicine division at Celgene, which was, how big was Celgene? 100 billion, 100 and something billion?
Yeah, we grew to $120 billion market cap at our peak. And Celgene was a remarkable place. The best people, I got to tell you, I was blessed to be part of that organization, the best leadership. science-driven and courageous. It was a great environment to be risk-taking, risk-tolerant, and innovative.
Yeah. Well, so at one point, I remember our conversations, and we said, listen, it's great environment, but you would thrive better if we could spin out the cellular medicine division. And that became Celularity. And folks can look it up. It's now a public company, CELU. And you built an extraordinary manufacturing facility that you're in the midst of right now in New Jersey. But it's worth taking a moment to say, when you harvest a placenta, and I do want to put in the show notes here, folks can go to lifebankusa.com, because again, I'm just shouting this from the mountaintops. As we're recording this podcast, I got a text from my sister and my mom that Christina has delivered. So her daughter,
congratulations.
Welcome to planet Earth.
I'm going to let the lab know that the placenta will be here shortly.
Yes, and her placenta and her child's placenta will be there. And what do you do with the placenta once you get it? And what are the products that you create? Take a second to speak about that.
So the placenta is procured under very rigorous controls, transported under controlled logistics, and then in our laboratories, it is processed to separate the cellular side of the organ from the tissue side of the organ. And from the tissue side of the organ, we make a whole range of surgical appliances. These are products that are used in wound healing, orthopedics, ophthalmology, and they are basically using the natural architecture of the placental tissue itself to come up with replacements for skin, ligament, tendon, cartilage, etc. And they are increasingly popular as the basis for treating diabetic foot ulcers, venous stasis ulcers, burns, etc. The cells go on to be used to produce immune cells, pluripotent stem cells, and a whole range of other products. And people can go to our website, celularity.com, CELULARITY.com, and see all these programs and products. But the bottom line is that we're a leading company in cellular and regenerative medicine, and we are perfectly poised to deploy all these therapies in the future of longevity therapeutics.
Amazing. Bob, I am grateful for you in my life. Thank you for the work that you're doing. And you've been an incredible scientist, CEO, engineer, and brother for me. I hope folks will check out what Celularity is doing, what Fountain Life is doing, and start to understand the power that stem cells have, and that it is part of our regenerative toolkit. It is part of our future. And it's, we hear about the idea of adding decades of health to our life. This is health span extension, right? And we hear of epigenetic reprogramming. But the other big area is cellular medicine, stem cells. We haven't even talked about really supplementing your immune system with NK cells and T cells and so forth. We'll leave that to another episode. But love you, brother. And thank you always for our time together.
Peter, I love you. Thanks so much for having me. And you're the inspiration that has gotten us here. So keep it up, man.
Thank you, pal.
See you soon.
See you soon.